In the previous chapters, we learned the point estimate and the confidence interval. Point estimate is we try to estimate the population parameter with sample statistic. For example, we use the sample mean to estimate the population mean. Confidence interval is we try to develop a range of the values within which we expect the population parameter to occur. For example, we develop a range of the values we expect the population mean to occur. In this chapter, we start to develop a procedure to test the reasonableness of a statement about a population parameter. For example, we see the mean speed, that is the average speed, the mean speed of the automobiles passing by the exit 25 on the highway 93 is 70 miles per hour. So this is a statement. What kind of statement? It's a statement about the population mean. Population mean here is the mean speed. So we assume all the cars who passing by the exit 25 is 70 miles per hour. So in this chapter, we try to using a procedure. We're gonna develop a procedure to test the reasonableness of this statement. Is this statement about the mean speed is acceptable or not? And we call this kind of the statement is a hypothesis. And the procedure developed to test the reasonableness of the hypothesis is tests of hypothesis, or we call that hypothesis testing. Okay, let's start with the one sample test of the hypothesis. Okay, let's check our goals for this chapter. We're gonna skip some part. Okay, so define a hypothesis and hypothesis testing. Describe the 5-step hypothesis testing procedure. Distinguish between a one-tailed and a two-tailed test of the hypothesis. Conduct a test of a hypothesis about a population mean. Okay, these are all we need to learn for this chapter. Okay, let's start with define the hypothesis. As I said, hypothesis is a statement about the value of the population parameter developed for the purpose of the testing. As our example, right? We had a statement about we want to know the population mean of the 70 miles per hour passing by the exit 25 on the highway 93. So our purpose, we developed that statement is for the purpose of testing. We want to know if that statement is reasonable. Hypothesis testing is a procedure based on sample evidence and probability theory to determine whether the hypothesis is a reasonable statement. So if we want to know that statement about the 70 miles per hour speed, average speed passing by the exit 25 is reasonable or not, it's very hard or kind of impossible for us to find out the average speed of all cars passing by that. But it's possible for us to find out the sample evidence, and using the sample evidence and the probability theory, we can determine if that statement is reasonable. Okay, so here pay attention to this procedure. So about testing that statement, there is a given procedure we need to follow. Okay, so from now on, when we do the hypothesis testing, please make sure you are following those 5 steps, including, in the exam, please write the complete 5 steps. Let's take a quick look for of these 5 steps. Maybe it's still hard for you to get it, but just take a quick look, and I will cover this in detail in the later slides. First step, state non and alternate hypothesis. Step 2, select a level of the significance. Steps 3, identify the test statistic. Step 4, formulate a decision rule. Step 5, take a sample, arrive at decision. So decision is do not reject non-hypothesis or reject non-hypothesis and accept the alternate hypothesis. Okay, we're gonna take a specific look at all of these 5 steps. So here, select a level of significance. Just remember the level of the significance. In every questions, this level of significance is a given information. Okay, is a given information, is already there. It usually means the probability that you reject a statement that is actually true. Okay, so the level of significance means the probability of you rejecting a true statement. Okay, now let's take a look one by one. So the first step, we need to make a statement of the null and alternate hypothesis. So what are the null and alternate hypotheses? Null hypothesis is a statement about the value of the population parameter developed for the purpose of testing numerical evidence. So, for example, the example we just used, the null hypothesis can be the mean speed is 70 miles per hour. Okay, the mean speed equal to 70 miles per hour. Alternate hypothesis is a statement that is accepted if the sample data provide sufficient evidence that the null hypothesis is false. So we can say the alternate hypothesis for our example is the mean speed. The mean speed is not 70 miles per hour passing by the exit 25. Some important thing you have to remember about the non-hypothesis and alternate hypothesis. Non-hypothesis always write as H sub O, okay, H sub 0. We use H sub 0 means non-hypothesis, and H sub 1 is used to represent the alternate hypothesis. Non-hypothesis and alternate hypothesis are mutually exclusive and collectively exhaustive. What does that mean? Means non-hypothesis and alternate hypothesis altogether already include all the possibilities of that event. Okay, so if we say the non-hypothesis is the mean speed of all the cars passing by the exit 25 is 70 miles per hour, then alternate hypothesis is the mean speed is not 70 miles per hour, is any other speed. So these two statements already include all the possibilities. There is no other possibilities. Non-hypothesis is always presumed to be true. alternate hypothesis has the burden of the proof. A random sample n is used to reject null hypothesis because we need to take samples, try to prove the null hypothesis is not acceptable. If we conclude after 5 steps, we have to make a decision, right? We have to get a conclusion. Do not reject the null hypothesis. This does not necessarily mean that a null hypothesis is true. It only suggests that there is no sufficient evidence to reject the null hypothesis. So rejecting null hypothesis suggests that the alternate hypothesis may be true. Equality. Okay, this one is very, very, very important. You have to know about this. Equality is always a part of the null hypothesis. So because when we make the statement, we need to write a formula, right? So for the null hypothesis, equality is always a part of the null hypothesis. So when you make a null hypothesis statement, please remember that null hypothesis always contains equal than, or greater than and equal, or less than and equal. Anyway, always equal than is always part of the null hypothesis. Because the null hypothesis and alternate hypothesis are mutually exclusive and collectively exhaustive, so alternate hypotheses are always includes or contains doesn't equal, less than, or greater than. Okay. I will help you understand all of the things in the examples if you don't get it right now, and don't worry. Okay, in the step 3, we mentioned about the test statistic. Okay. Test statistic is a value decided from sample information used to determine whether to reject a null hypothesis. So, test statistic, we actually will, provide a formula, and you're gonna use that formula to calculate a value. Okay, to calculate a value, and in that formula, we need the data from the samples. Okay. We're gonna use that to decide whether to reject the null hypothesis. Well, in the step 4, there is a decision rule, right? There is a decision rule. So the decision rule actually is compare the test statistic, compare the value we get from the test statistic calculation to a critical value. Decision rule is compare these two numbers, two values. So critical value is a dividing point between the region where the null hypothesis is rejected and the region where it is not rejected. The critical value is actually decided by the significance level. Remember, the step 2, is decided the significant level. Usually the significant level is a given information, and I told you the significant level is a probability you reject the null hypothesis when it's true. Okay, so critical value decided by that, and you will be provided with the test statistic formulas. Then we're going to compare the two numbers. How do we do that? And also how understand that. If you feel very, very confused right now, then please do not worry. We will figure it out in the examples. Okay, just now I talked a lot of things about the null hypothesis and alternate hypothesis. When we make a statement, I said the equal sign is always a part of the null hypothesis, and then the equal or less than and greater than part of the alternate hypothesis. So when we start to deal with the specific questions, and a lot of times you very easily get confused. You don't know how do you assign the sun to your statement. And this slide is very useful and very important for you to get everything right. I mean, you will, because you need to first make your statement correct, and then you can start your procedure to test your statement. Okay, so this table is something you have to keep in your mind. If you cannot, but at least when you do your homework or the exercise or your exam, you need to check this table until you get that you be very familiar with this table, and you will not make any mistakes. In actual practice, the status quo is set up as this non-hypothesis. Okay. So in problem solving, looking for keywords, then convert them into the symbols. Some keywords include improved, better than, as effective as, different from, has changed, like this. So, for example, keywords larger than or more than. When you see these kind of keywords, that means the sun will be the greater than sun. Will be the greater than. The greater than. If the sun is greater than, as we mentioned, greater than is a part of the alternate hypothesis. So you need to write the alternate hypothesis statement first. When you know the alternate hypothesis is greater than sun, can you figure out the sun for the non-hypothesis? Yes, non-hypothesis will be the less than and equal sun. If the keyword is smaller or less than, then how do you translate the smaller or less than into the mathematical symbol? It's less than, right? And again, less than is part of the alternate hypothesis. So when you write down the alternate hypothesis, and you will know in the non-hypothesis, the sun will be the greater than and equal. If the keyword is no more than, then the symbol, the sun, will be the less and equal. Because this contains equal sign in, so it's part of the non-hypothesis. So once you know the non-hypothesis is less and equal, can you figure out the sun for the alternate hypothesis? Yes, that will be the greater than sun, right? At least is greater than and equal. That is, again, because it contains equal sign, so it will become the part of the non-hypothesis. So if you know the non-hypothesis is greater than or equal, do you know what's the sign for the alternate hypothesis? Yes, it is less than. Has increased is greater than, so it's part of the alternate hypothesis. So non-hypothesis will be the less than and equal. Is there difference? Means that's not equal. That will be part of the alternate hypothesis, and the non-hypothesis will be the equal sign. Hasn't changed is equal sign, so it's part of the non-hypothesis. Has improved is better than, is more effective, means improved means greater than, better than means greater than, more effective, that's depends on the text. So remember, please, when you do the exercise or the homework, check this table, be familiar with the symbols, and know which part the part is belong to which statement. Okay, let's check this one tail or two tail test. I know now you must be very confused. You don't know what's going on, and no idea for a lot of stuff just in every slide, and they are not even connected to each other. Seems those kind of stuff do not make any sense, but just be patient, okay? One tail and two tail test. So if in your non-hypothesis the sum is equal sum, for example, non-hypothesis is the mean speed is equal to 70 miles per hour, and your alternate hypothesis is mean speed is not or doesn't equal 70 miles per hour. And that kind of statement, we're gonna use two tails, okay? Two tails. So when the null hypothesis is equal sum, alternate hypothesis is doesn't equal sum, that will be the two tails. Okay, two tails. If the null hypothesis is greater than and equal, and alternate hypothesis is less than sum, then we're gonna use a left tail test. Remember, left tail when the non-hypothesis is greater than and equal. If in the non-hypothesis the statement contains the less than and equal sum, means the alternate hypothesis is greater than sum, then it's right tail test. Okay, right tail test. So here I just want to show you, because there is a graph here, right? So actually the statement, the hypothesis testing is we use test statistic, that formula, find out a value, right? And using the significant level, we find out the critical value. Critical value will be here. Okay, for the two tails, it will be here and here. So we're gonna compare the test statistic value and with this value. If test statistic value follow is greater than 1.96, this critical value, or less than minus 1.96. If that happens, then we're gonna reject the non-hypothesis. If the value you got from the test statistic formula is less than 1.96 or greater than the negative 1.96, then we're gonna accept the non-hypothesis. For the left tail, if the value you get from the test statistic is greater than this critical value, okay, greater than the critical value, then we do not reject the non-hypothesis. If for the right tail test, if the value you get from the test statistic is less than the critical value, then we do not reject the non-hypothesis. But if that greater than the critical value, we're gonna reject it. Okay, I know still, a lot of stuff you still don't get it, but just wait. We will continue to introduce our information, introduce our concept, and then in the example you will understand what I said. Okay, now here is the test statistic you're gonna use. Okay, please ignore this part, because I'm gonna skip this part in this class. Okay, the t value. So skip this one, and this one, and this part. Only pay attention to the one with the z value. Okay, with this one, and this one. So here is a test statistic formula. What I mentioned in the last slide, I said, okay, the decision rule is you're gonna compare the value you got from this formula, okay, with the critical value. I will let you know how to find out the critical value later, but now you know how do you find out your test statistic value, okay, with this formula. X bar minus mu over sigma divided by the n square root. So X bar is a sample mean. X bar is a sample mean, the mean number for the sample. Minus mu is the population mean, okay, is the mean number we try to test, okay. As what I said, we state the mean speed is 70 miles per hour passing by the exit 25 is 70, right? So that is our population mean. Well, we take a lot of samples, some cars passing by with a speed of 65, some cars passing by with a speed of the 60, some cars with the speed 78, some cars with all sorts of the speed limit, not speed, with all sorts of the speed, and we just add them, all of them up and divided by the sample size. Then we find out the sample mean. So sample mean minus the population mean and divided by sigma. Here is the population standard deviation, right? So if we know this population standard deviation, we use sigma. Sigma divided by the sample mean, take a square root. We're gonna get the value with this formula. We call that test statistic. Remember, we're gonna use this value to compare with the critical value. Okay, come back up here. So this is a statement. This is how we make our statement, okay? That is how you write out your statement for the step 1. Remember, 5 steps. The first step, you need to make the statement. How do you make your statement? Like this. For example, your statement will be like non-hypothesis HO mu equal to certain value. Mu is population mean. Population mean equal to a certain value. Then alternate hypothesis will be the mu does not equal certain value. We call that two tails, okay? If your statement look like this, that will be two-tail testing. And your decision rule will be the z-value. This z-value you got from this formula. This formula. Decision rule will be the absolute value of the value you got from this formula greater than this z alpha sub alpha divided by 2. This z alpha over 2 is a critical value. Okay, it's a critical. How do we find this out? I will let you know later. If your statement is non-hypothesis equal to mu greater than and equal to certain value, alternate hypothesis is mu less than certain value, then your decision rule will be your test statistic less than negative critical value. You're gonna reject your non-hypothesis. If your statement is hypothesis, non-hypothesis is mu less than certain value, alternative hypothesis is mu greater than certain value. Mu is population mean, okay? You reject this non-hypothesis statement if test statistic, this value, you get with this formula. Test statistic greater than the critical value. Okay, critical value. So another thing you need to pay attention is this is two tails, these two are one tail, right? For the two tails testing, the critical value here is alpha over 2. What is alpha? Alpha is significance level. Remember, I said in the step 2, you need to decide the significant level, and the significant level is a given information. For the two tails testing, you need use alpha divided by 2. For the one tail testing, is use alpha. Okay. So how do we find out critical value? I will let you know in the later slide. Okay, finally, example. If you feel very confused, then please pay attention to the example. We try to solve all the problem in this example, and also through this example, help you understand how do we, do our hypothesis testing through the 5 steps. Gemstone Steel Company manufactures and assembles desks and other office equipment. The weekly production of the Model A325 desk at the Fredonia plant follows a normal probability distribution with a mean of 200 and a standard deviation of 16. So you will know the given information here is the population mean is 200 and the population standard deviation is 16. Recently, new production methods have been introduced and new employees hired. The VP of the manufacturing would like to investigate whether there has been a change in the weekly production of the Model A325 desk. So the keyword here is has been a change. So what will be the statement? What will be your non-hypothetical statement? Let's go back, check our table. Has not changed or has changed or has not changed. It's an equal sign. Okay, it's an equal sign. So let's check these examples out. Statement. Step 1. State. Okay, if you do read a homework or do any exercise, please, just write as this example does. Follow the steps. Step 1. State the non-hypothesis and alternate hypothesis. You need to write it this way, okay? Non-hypothesis, mu equal to 200. Non-alternate hypothesis, mu does not equal 200. Note, keyword in the problem has changed. We're going to use equal sign, right? So, because we already, this is the statement about the population mean. So we want to know if the population mean still the 200 has changed or not. Step 2. Select a level of significance. This is a given information. It's not in the slide, but in the textbook. For this example, the level of significance is 0.01. So alpha equal to 0.01. Step 3. Select the test statistic. We use a Z distribution since sigma is known. For this class, we only consider the population standard deviation is known. This kind of situation, so we only use the Z distribution. Okay. So select test statistic because we're gonna use the Z distribution, right? So just ignore this sentence. Because we will not use the T distribution. We will not use other distribution in this class. So select test statistic. The formula will be the Z equal to X bar sample mean minus mu population mean, then over sigma divided by the sample size take square root. So you're gonna use this formula. This is another thing I just want to suggest to you is when you read the questions, please on the paper you just list all the given informations. For example, in these questions, you list you are given information like first the x bar equal to what's the x bar here is okay. In the slide, the question is not complete. The complete question will be in the textbook, page 336. Okay, page 336. So in the textbook, the example, the questions telling you, under the new product method introduced, and they produced 203.5 products, 203.5 products, and the sample size is 50. Sample size is 50. So what I said is you just list all the given information. X bar equal to 203.5, and mu is 200, and standard deviation is 16, and n is 50, and alpha is 0.01. Okay, alpha is 0.01. That's easier for you to solve the problem. Okay, step 4, formulate the decision rule. Decision rule is what we covered in the previous slide. Reject your null hypothesis if the absolute value of your test statistic greater than the critical value. So here the test statistic, the value you get from this formula. So 203.5, that's the sample mean minus 200, the population mean, divided by the standard deviation 16 over the 50, the sample size, take a square root, and you get the 1.55. Okay, 1.5. Okay, here the key is how do we find out the critical value. Critical value here is expressed as z sub alpha divided by 2. Remember, because this is 2 tails, right? So it's alpha divided by 2. If it's 1 tail, it's z alpha. Okay, it's z alpha. So, okay, how do we find out the critical value? Critical value here, let's check this graph first. Actually, I suggest you for all the hypothesis testing question, please draw the graph to help yourself. Okay, so these are 2 tails. So there are 2 critical values here. Okay, actually, this blue area, blue shaded area together is Z alpha. Okay, is Z alpha. So these 2 tails, the blue area, shaded area all together is equal to Z alpha is 0.01. It's 0.01. So this 0.01, so it's because there's 2 tails, 0.01 divided by 2. 0.01 divided by 2, say here, 0.01 divided by 2 will be the 0.005. So each tail is 0.005, each tail. And this 2 point, is the critical value. We need to find out the z value for this 2 point. Okay, so just recall how we find out the z value for this 2 point. If we want to find out the z value for this 2 point, we need to find out the area of this area. Okay, so from here, this half, we need to find out this half. If we know this tail, one tail is 0.005, found by 0.01 divided by 2, we got a 0.005. Then we will know this half until here is 0.5 minus 0.005. It equal to, let me bring here to show you. Okay, so let's go back. Alpha is 0.01, right? Then that's the whole blue area. We divide it by 2, we get the 0.005. That is the area for the one tail, one blue shaded area tail. Then what we need is this half. Then we use 0.5 minus 0.5. That is, we need to use a 0.5 minus this blue tail, we get this part is 0.495. Okay, I just take the shortcut. Actually, I need to write that as 0.5. So remember, the whole area under the normal probability curve, normal distribution curve is 1. So this half is 0.5. 0.5 minus this blue area, this one tail is minus 0.005. So we get the 0.495. So this half is 0.495. Once we know the area of this part is 0.495, we can find out the z-value of this point. Check our z table. Okay, find the 0.495. Where's the 0.495? Okay, 0.495 is here. 0.495, it's close. If we find out the two numbers close to 0.495, we go up the larger one. Okay, so it is, when you find out the area is 0.495, go horizontally to the first column is 2.5. Then from the 2.495 go up. Go up to is 0.08. So the z-value for the 0.495 is 2.58. Is 2.58. So go back. So 2.58. Okay, this is how we find out the critical value. Again, I repeat that again, okay, because this is the hard part every year for the students. You know your alpha, the significant level is alpha, right? So in this question, alpha equal to the 0.01. Because it's two tails, so we need to use the 0.01 divided by 2. We get the 0.005. That is the area for the one tail, one for this blue area. So if we want to find the z value for this point, that is the critical value, then we need to find out the area for this part. We're gonna use the 0.5 minus the blue area, right? So 0.5 minus 0.005, we get the 0.495. Then we go to the z table, find out the z value corresponding to the 0.495 is 2.58. Okay, so we get the critical value of 2.58. We use the test statistic we get from this formula, 1.55 compare with the 2.58. Then 1.55 is not greater than 2.58. What does that mean? Means the test statistic fall into the do not reject region. So the conclusion we can get is do not reject our non-hypothesis. What is our non-hypothesis? Our non-hypothesis is the mu is equal to 200. Means even using the new population method, even though we use a new production method, but there is no change. Okay, so check this out. Make a decision and interpret the result. Because the 1.55 does not fall into the rejection region, non-hypothesis is not rejected. We conclude that the population mean is not different from 200. So we would report to the vice president of the manufacturing that sample evidence does not show that the production rate at the plant has changed from 200 per week. Okay, now let's check the one-tail situation. If, suppose in the previous problem, the vice president wants to know whether there has been an increase in the number of the units assembled. To put it another way, can we conclude because of the improved production method, the mean number of desks assembled in the last 50 weeks was more than 200? Yeah, more than 200. So when you look at the more than 200, what's pump up in your mind. More than, the keyword means greater than. Okay, so greater than 200, that is a part of which statement? Yes, alternate hypothesis. So in the non-hypothesis, it will be the less than and equal to 200. Okay, recall the sigma standard deviation is 16. N is not 200. Here is a typo. Okay, it's not my fault. It's the slide from the textbook from the publisher. It's mu. Okay, population mu is 200. Alpha equal to the 0.01, and the x bar is 2. Remember 203.5, and n is not 200. N is 50. Okay, let's check this example. So now the statement will be, say, like this. The non-hypothesis is mu less and equal to 100. Alternate mu greater than 200. Okay, when this will be the one-tail test. Just remember, try to recall what I said. Is when the mu is less than or equal, right tail. If the mu is greater than or equal, left tail. Okay, so please, when you do any questions like this, draw the graph to help you understand which tail is this. So this is one tail, and for the one tail, our alpha, the significant level, will be here. It's 0.01. Compare the difference. Okay, for the two tails, so when your alpha is 0.01, and each tail will be the 0.005, because the alpha need to be divided by 2. And for the one tail, then the whole rejection area will be the 0.01. Okay, so if it's one tail and this part is 0.01, how do we find out the critical value? Remember, okay, so we need to take the half of this distribution, right? So the half is the area of the half is 0.5. So this area will be the 0.5 minus 0.01. Then the result is 0.49. Okay, so 0.49. Let's go to the Z table. 0.49. 0.49 is, I found it. Okay, 0.49. The Z value for the 0.49 is go horizontally is until the first column is 2.3, and go up vertically to 0.03. So the Z value for the 0.49 is 2.33. So see, 2.33. That's how we find out the critical value. Then let's check the test statistic. So, okay, from the beginning, how do we do this question? Step 1. Remember, always write down the steps. Okay, in the exam, please write the full 5 steps. In that way, if you make any mistake in, some steps, I still can give you credits for your other steps. Please do not just jump into the conclusion directly. Step 1. State the non-hypothesis and alternate hypothesis. Non-hypothesis is mu less than and equal to 200. Okay, means population mean is less than and equal to 200. And alternate hypothesis is mu greater than 200. How do we know this? From the keywords in the problem and increase. Step 2. Select the level of the significance. Alpha equal to 0.01 as stated in the problem. That's given information. Step 3. Select the test statistic. We're gonna use the Z value, right? Is the Z equal to X bar minus population mean mu divided by sigma over N, take a square root. Here you go. So We use that way find out the 1.55 for the test statistic, and we already found out our critical value, right? 2.33. If you have questions about how to find out the critical value, please check what I just taught for the last slide. If you still cannot get it, just send me email, ask me. Okay, here is always the part the student can not easily get it. So that's understandable if you have a problem with it. Step 5. Make decision and interpret the result. Because the 1.55 does not fall in the rejection region, so null hypothesis is not rejected. What that means we conclude that average number of desks assembled in the last 50 weeks is not more than 200. Okay, it's not more than 200. Just one little thing here is type of errors in the hypothesis testing. Type 1 error, defined as the probability of rejecting the null hypothesis when it is actually true. It is denoted by the Greek letter alpha, also known as the significance level of the test. Now you get it, right? So actually the significance level of the test, the given information always is alpha. It is, we call that type 1 error. What that means the probability of rejecting the null hypothesis when it's actually true. So for example, in this graph, this shaded area is alpha. Okay, so it's alpha. So this shaded area decided the critical value here. Then that's why we're gonna use a test statistic compare with this critical value to say if the test statistic follow into the region of rejection or the region of the non-rejection. So if falling into the region of rejection means we're going to reject our null hypothesis. If in this area, that means we're going to accept our null hypothesis. Okay, so this chapter just is the core content of the basic, introductory level statistics. You have to make sure you understand it, and it's hard to understand. So if you have any questions, please contact me by email.